Hello, I am audible. Please just confirm me. You can write in the message also. You can write in the chat box if I am audible. Okay, okay. Let us wait 5 minutes. Maybe another participants will join. Then after we'll start. Okay, let us start. So the first question is a very thin region of flow near a solid wall where viscous force and rotationality cannot be ignored is called inviscid region of flow, irrotational flow, boundary layer, or outer flow region. So please, based on your understanding with NPTEL videos, you please try to give your answer. By the way, I am Om Prakash Maurya from IIT Guwahati. So this is the week number 11. Okay, so you are telling option C is correct. Okay, let me see and little bit discuss about more student. Okay, so we are talking here. Let me just take the pen. A very thin region near the solid wall where the viscous force and rotationality cannot be ignored. Means what? Let us suppose a solid wall. I want to take a plate, or you can take pipe also, because pipe having also solid walls. These are the solid walls, or open channel also. These are the also solid walls. So I'm taking the here plate, then a very thin region. What is boundary layer? Let me first in try to explain. So here, if I draw the velocity diagram, if this is x direction, this is y direction, your velocity will be like that. One more I will drive, then after a straight, after this a straight, after this a straight. After that it will be constant after some extent. So it means what? Here I am just showing you the zoomed view. It is very thin. If I try to draw here very thin things, so it is very, let's suppose like that, very thin. But just here I am trying to show you in the zoomed view. So boundary layer is nothing but up to that extent your velocity is varying. After that your velocity almost equal to free stream velocity. That is 0. Or 99% of the your u infinity. U infinity means your free stream velocity. So in that layer, if you want to derive some mathematical equation, in that layer we cannot ignore the viscous force and rotationality force. So this is the meaning. And what is the advantage of this? So we'll discuss advantage later. What is the advantage of this? uh, Whether up outer the, that is the inside the boundary layer we cannot ignore, but outside the boundary layer we can ignore the viscous force, because it is related to Reynolds number or the viscous force. You can talk, you can tell viscous, it is related to the viscous force. I'll tell later. Next question. So here I have written very well what is the viscous effect and all. If I try to explain here what is viscous effect. In the boundary layer, the viscous force within the fluid become dominated. Viscous force within the fluid dominated in the boundary layer. And viscosity is a property of fluid that resists shear deformation or flow. In the boundary layer, the fluid molecules near the wall experiences a strong frictional force and leading to velocity gradient from 0 to 0 at wall and to the free stream velocity away from the wall. And this velocity gradient is responsible for the deformation of the boundary layer. So here is the meaning. Just try to understand. Due to the your viscosity and the friction of the wall, here velocity is zero. This effect is propagated above and above. So velocity diagram is like that. After that, the effect of your wall and viscous is less. So that's why here is a little bit straight pattern of the your velocity diagram. So overall, this idea will understand more. So here I have written everything. What is rotationality? What is the flow separation? I have also written here. About heat transfer I have also written. So one by one you can go through, and once I will upload in the folder. Now we'll move on the next question. Next question is about question number D. Question number two. Question number two is, which option is correct regarding the boundary layer approximation? First, the higher the Reynolds number, thinner the boundary layer. Option B, boundary layer approximation may be approximate appropriate for the free shear layers. Option C, the boundary layer equation are approximation of Navier-Stokes equation. Next, the boundary layer approximation bridge the gap between Euler equation as well as your Navier-Stokes equation. And option C, E, all of the above. All option correct or not? Which option is correct? You just please try to give your answer in the chat box. So question number two. Please read question very carefully one by one, and which option is correct, please try to find out and write your answer in the chat box. You have 2-3 minutes for this question. Okay, you are telling option E. Okay, I'm waiting for another response. Another one response. So let me discuss. So here is the first option is higher the Reynolds number, thinner the boundary layer thickness. So if I talk about some result which is conducted by the Blasis experiment, if your boundary layer laminar, then delta, that is the boundary layer thickness, divided by distance from how much, what is distance this, let me just, this is the distance, this side, x, and 5 by root under Re. This equation for your laminar as per the Blasis. Next, for turbulent, he has given delta by x is equal to 0.376 divided by Re to the power 1 by 5. So this is the overall formula. In both cases, your delta is inversely proportional to Re, means if your Re will be more, delta will be less, because it is inversely relationship. So in this statement, in statement 1, higher the Reynolds number, thinner the boundary layer. It means this is correct. Here I have just shown you. Boundary layer approximation may be appropriate for free shear layers. Here is the meaning, boundary layer approximation may be appropriate for the free shear layers. First we try to understand what is the shear layers. Shear layers is nothing but, let us suppose if I try to explain in terms of open channel. So if this is, you will be understand very easily here. If this is the cross section of flow, in this, here is the velocity 1, here velocity 2, here velocity 3. Definitely your velocity 1 will be more than velocity 2. So in this region your velocity will be more, in this region velocity will be more compared to V2. So here velocity is less, here velocity is more. So at that location, what will happen? Low velocity zone and high velocity zone will be interact, and this zone is known as shear layer zone. So here one zone will be formed, which represent just the separation of your high and low velocity. So here is the boundary layer approximation. Maybe in case of pipe flow, you can just think if the pipe flow is like that. So here also, if the flow is laminar, your velocity distribution like here is less, and then parabolic, here is parabolic, this is a parabolic. So like that means what? Here also your separation, one zone will be exist. What? That is the, I am talking about this zone, because here the less, and in between the very high velocity, if I write here V1 and V2, definitely your V1 will be more than V2. So definitely one shear layer zone will be exists. So here the boundary layer approximation may be appropriate for the shear layer, definitely it will be uh, yes, it is appropriate for shear layers, free shear layers. Next, boundary layer equation are approximation of Navier-Stokes equation. Yes, definitely. The boundary layer approximation bridge the gap between Euler equation as well as the Navier-Stokes equation. Yes, Euler equation and Navier-Stokes equation, and all of the, yes, all option is correct. Why I am talking about here the Euler equation and the Navier-Stokes equation? Because in Euler equation we not consider the force. Simply in Euler equation we write is equal to force is equal to mass acceleration. In Navier-Stokes equation also we write the force is equal to mass into acceleration, but here we not consider the shear force, here we consider the shear force. So this is the difference between Euler equation and the Navier-Stokes equation. So here all option is correct, option E. Next question. Next question is, which one of the following is not a flow region where the boundary layer approximation may be appropriate? Jet, inviscid region, wake region, thin region near the solid wall. Which option is correct for question number 3? Please try to give your answer in the chat box for question number 3. For question number 3, which option will be correct? Please try to give your answer in the chat box. So please everyone try to give your answer in the chat box. I am waiting. So within 2-3 minutes, just revise your, brush up your mind and think on that and try to give your answer. So after that only 1 week is remain, but I'll take the 2-hour extra session. Just I will solve some important question in the extra session. So it may be on 16. Okay, you are telling the option B. Which one of the following is not a flow region where the boundary layer approximation may be appropriate? So you are telling inviscid region. Okay, let me discuss little bit. So yes, you are correct. Inviscid region is correct because boundary layer approximation come due to your viscous effect. If viscous effect is not there, then there is no meaning of boundary layer approximation. Next question is, here I have written, you just go through explanation. Yes. Question number 4. The flow along a flat plate with x being the distance from leading edge, the boundary layer thickness grow like. Option A, B, C, D, which one is correct? Please try to give your answer. We are talking about here boundary layer thickness. Delta. You are telling option A. Okay. Okay, let me discuss. So we are talking about here the flow along a flat plate, means theta is equal to 0, flat plate. So the x is start from here. This is your leading edge. Okay. The boundary layer thickness grow like that. Means what? This is. We are talking about this thickness. Here is delta 1. Here is delta 2. Here is delta 3. So like that. How delta varies with respect to x. Whether it is x, whether it is root x, whether it is x square, whether it is 1 by x square. This is a or 4 option, A, B, C, D. So one student is telling option A. Okay. So just few minutes back, what I have just tell you, the relation between, for if we are talking about laminar flow, delta x x divided by 5 root Re. For laminar flow, for turbulent flow, delta by x equal to 0.376. It may be different for, this is as per the your Blassius. It may be different for other, maybe other researcher done the experiment different way, carried out experiment different way, so maybe the this fraction will be different. This part will be different. But overall, the relation between here, if I talk about the delta is, if this is constant, your delta is directly proportional to x. But please remember, this is not like that. Always remember, this is not like that. X means what? X means what? A straight line equation. That is, y is equal to, if I write x, means what? Y is equal to mx. That is the equation of a straight line. It means it will be grow like that, straight, not like that. So remember please, your, don't be confused from this equation. From this equation, your delta grow like proportional to root x. Always remember please. Always remember, option B will be correct for question number 4. Now we'll move on the next question. Question number maybe 5. Yes. This is given by Blassius for laminar boundary layer over the flat plate. Remember please, we are talking about here the laminar boundary layer. Next question. Question number 5. The nominal distance of a boundary layer is defined from the wall to a point. The nominal distance from a boundary layer is defined from the wall to a point where the velocity is 99% less than the asymptotic limit, where the velocity ceases to laminar, where the velocity is within 90% of the asymptotic limit, where the velocity is 99% of its asymptotic limit. So which option is correct for question number 5? So you please try to give your answer. Okay, so please remember whatever I have earlier discussed. Question number 5, if just, okay, you are telling option D. Okay, I'll wait 1 minute more for other response. I have just discussed about this in question number 1. So this question is related with my explanation of question number 1. Syam is telling option D. Okay. Okay, let me discuss. So here we are talking about 99% concept. Yes, you are correct. So if we take one plate, same explanation I will give here. So this is your boundary layer. So if this is y direction, your velocity will be like that. After that, it will be little bit not varying much. Here vary up to that, then after free stream velocity is your denoted by, if I denoted by u infinity, so this is your 99% of u infinity. Remember please, this is your 99% of u infinity. So remember, so we are talking about this thing only. So nominal distance from the boundary layer, now nominal distance of the boundary layer is defined as, that is your this distance, how much, this distance how much, from the wall, this is wall, to a point, this point, where the velocity is 99% of its asymptotic limit. Means whatever the your state, that is the your, there is no change in velocity, it means up to 99% of your this limit, that is u infinity. Remember please, this is about question number 5. Now we'll move on the question number 6. Question number 6 is, the maximum thickness of boundary layer in a circular pipe of diameter r can be given as r by 2, r0, 2r. We are talking about here the maximum thickness of boundary layer in circular pipe with diameter r. So which option will be correct? Please try to give your answer. Just please try to think on that. In first question, I have also explained the pipe things, how your velocity propagate in pipe flow. So if you will think more, definitely you can give answer of this question very easily. Question number 6. So I'll wait 1 minute more. Please try to give your answer. Okay, you are telling option number B is correct. Okay, I will discuss. Okay, let me discuss. So we are talking here the maximum boundary layer thickness in a circular pipe. If I draw a circular pipe, let us suppose the diameter of this pipe is R. Diameter is R, not radius. This is the diameter of R in the question is given. So it means the half of this distance will be R by 2. This side also R by 2. Earlier I have explained what? Your velocity diagram in case of pipe flow, if flow is laminar, it will be varies like that. If this is your midline, parabolic kind of thing. I have tell you this is the maximum V max. One thing I want to also tell, V max is equal to your, if I average this diagram, so this is the 2 times of V average. This is out of discussion, there is no meaning, but just for your remember I have. So here, now let's concentrate on these things. So we are talking about here the maximum boundary layer. So if I draw here the boundary layer, if I try to draw the boundary layer, it will be like that. From this side boundary layer also will come, from this side boundary layer also will come, because pipe is circular. From every side your boundary layer will be come, and it go up to that much maximum extent. After that it will be meet from here. A boundary layer from, let me forms from here, so it will be here and this side boundary layers at the same time. If this is this formation same time, this formation, so it will be go up to only that much distance, that is your R by 2. Means diameter, if R, your maximum boundary layer thickness, hope you got it, maximum thickness of boundary layer is dia by 2, means R by 2. Which option? Your A option will be correct. Remember please always. How it form and all I have explained. So now we'll move on the next question. Next question is question number 7. the boundary layer form as the flowing fluid come in contact with the solid surface because of the action of force due to gravity action on the fluid, adhesive force, surface tension force, and the viscosity of the fluid. So please think on that and then try to give your answer. Question number 7. Question number 7, please. This question is your related with some previous questions. So if you just recall your previous whatever I have discussed here today, then you can very easily give the answer of this question. Okay, let me discuss for question number 7. So question number 7 is about your the boundary layer formation as the flowing fluid come in contact with the solid surface. Here I will again draw the plate things. Here is water. Let's suppose your water is flowing like that. When it come with contact with your this solid wall, what will happen? In the fluid, the viscosity is present. You know already. Here, due to the roughness of this, your solid wall, no slip condition you know about very well. So what will happen? This plate try to, firstly, this plate will try to reduce the velocity of the first layer, or maybe the zero of the, and finally it will be zero, the just adjacent layer of the this plate, that is here velocity is zero. After that, this effect will propagate in upper layers. Due to what? Due to viscosity. Because let us just you assume, if viscosity is not present in the water, in the flow, that is your fluid, what will happen? If viscosity not present, what will happen? This layer will not try to resist this layer, or this layer will not try to resist this layer, or this layer will not try to resist this layer. Viscosity need to be must present in your fluid, then it chance to your velocity will be like that. Because here zero, here is water flow, but here is the effect of no slip propagated due to what? By the viscosity, and this effect carried forward, carried above direction by what? Your viscosity. Remember please, if viscosity is not there, only no slip condition is valid here only. If viscosity, then what will happen? Your effect of wall roughness will be propagated in the above direction. This layer will, because the effect of no slip and the effect of your viscosity, your boundary layer will be formed. After that, your the effect of wall will be reduces, and then after your flow will be like that. There is no change. Here is also similar way. Just please try to think what I am telling. Similar way it will be straight. So viscosity of the fluid is very important for the your formation of boundary layer. Remember please. Next question, we'll talk about question number 8. Question number 8 is, the following boundary condition exists at the wall. The following boundary condition exists at the wall in the boundary layer. If A is equal to U, if dp by dx negative, if tau is equal to 0, if u is equal to 0, v is equal to 0. Which option is correct please? Just think on that, what I have just discussed in the previous question. If you will think very well, definitely you are able to give the answer of this question. Okay, you were telling for previous question or okay. So you are asking about the velocity is equal to 0 or velocity is equal to constant, or you are just telling the answer of this, the above question? For this question you are telling option D. Okay. So I will explain. Just please, I'll wait for another response from other participant. So okay. dp by dx is nothing but just the change of pressure with respect to x. As you move in the x direction, that is the flow direction, how your pressure will change. Okay, let me discuss. So we are talking about here the boundary condition exists at the wall. Y equal to 0 means what? If let us suppose I am just taking the pipe, you can take also open channel, you can also take plate. Y is equal to 0 means here we are, we are considering y in the vertical direction. Everywhere the same coordinate system. Means y equal to 0. Here y 0 as well as x also 0. So if I draw this line here, means at that point, if this is here, at that point, if this is here, at that point we are talking, this is about the question. The following boundary condition exists at the wall in the boundary layer, means at the boundary layer you know already due to the no slip condition your velocity will be 0. Velocity will be 0 means what? All three direction velocity. If flow is three dimensional, all three dimensional. If flow is two dimensional, then all your 2D velocity will be 0. So your option D will be correct for question number 8. Remember please. Now we'll move on question number next question. So next question is okay. The laminar sublayer exists only in the laminar boundary layers, in all turbulent boundary layers, only in smooth turbulent boundary layers, only in rough fully developed turbulent boundary layers. So I want to take 5 minute break, then after I will explain about it. You can also take 5 minute break, otherwise you can give the answer of this question. Hope student will join after few minutes. So I'll wait 2 minutes more. Then after I'll explain the question number 9. Okay, let me explain the question number 9. What question 9 is telling? The laminar sublayer exists. So we are talking about laminar sublayer. If I draw the boundary layer on a plate, so it will be like that. Here is the laminar sublayer exists. Plate. This is the laminar sublayer. This is the laminar sublayer. Up to that much, laminar zone. This is your leading edge. This is your transient, and after that this is your turbulent, and this is transient. So laminar sublayer region exists in turbulent boundary layer. So here the laminar sublayer exists only in laminar boundary layers, in all turbulent boundary layers, only in smooth turbulent boundary layers. Here is difference is smooth. Here in all turbulent. Only in rough, fully developed turbulent boundary layer. So here is rough, fully developed. All three turbulent boundary layer, here is also turbulent boundary layer. Only difference here, we are talking about in all type of turbulent boundary layer is smooth and rough. So here is the question like that. So if you will see the diagram, you can very easily give the answer of this question. So in all kind of turbulent boundary layer form, in all turbulent, that is the in all turbulent cases your boundary layer will be formed, whether it will be rough, whether it will be smooth. This is the whole idea. Now we'll move on the next question. Next question is which question number 10, which of the following theory is an approximation of Navier-Stokes equation? Approximation of the Navier-Stokes equation: Bernoulli's theories, Hooke's law, Stokes law, boundary layer theories. The approximation of the Navier-Stokes equation. So please try to give your answer. Just we have discussed about the such type of question in the previous, maybe question number 6, 7. So please try to give your answer in the chat box. So will not take much time in this question. So question number 10, the answer of question number 10 is, we have already discussed the approximation of the Navier-Stokes equation is your boundary layer theory. Next we'll move on the question number 11. Question number 11 is the variation of wall shear stress, the variation of wall shear stress tau omega or tau w you can say, from the leading edge of the stationary plate X can be related as. So please just try to give your answer. And we are talking about here laminar flow. Which option will be correct? Based on this concept, we have questions. So please just think on that. You try to give your answer. So please try to give your answer for question number 11. Then after I will discuss question number 9 and 10 for you. Please first try to give your answer for question number 11. Okay, you are telling option A. We are talking about here laminar flow, so please consider these things. Okay. So let me discuss. So the question is about the plate is stationary. The velocity of plate is 0 here, and I am interested to know about the your shear stress and this distance relation, whether it will be 1 by root x, whether root x, whether x, whether 1 by x. These four option is given. Previously, just I have told you, this is directly proportional to, that is I am talking about boundary layer thickness, root x as per the Blasis. Similarly, your tau is, that is the shear stress, variation of wall shear stress. We are talking about W is equal to here wall shear stress, is directly proportional to, inversely proportional to root x. So remember please. So option A will be correct. Yes, you are correct. Now we'll move on the next question. Next question is, water flow at 20 °C with a velocity of 1.1 meter per second over a flat plate whose length is 20 centimeter. length is 20 centimeter. Remember, the boundary layer thickness at the end of the plate is, so we are interested in the boundary layer thickness at 20 centimeter. The density and viscosity of the water is given here respectively. So please just think on option E, F, G, H. Which option will be correct? So please think on that and how you will solve. Just think on that. So you have 5 minutes. Please try to give your answer. Okay, let me discuss. For question number 1. That is question number 12 here. So we need to calculate boundary layer thickness. You know the formula or two formulas, delta by x 5 by root RE. Another formula, this is for laminar flow. Another formula, delta by x 0.375 RE to the power 1 by 5. 376, not 5. So this is for turbulent. So in question, first you need to find out whether your flow is laminar or turbulent. So how you will calculate? Using the Reynolds number formula, rho v x divided by mu. So x here is distance from where the solid surface start, means this one is x. In this question is x is given 20 centimeter, means 0.2 meter. Rho is given, mu is given, and velocity also given. So RE is equal to 1000, that is 998, already given in the question, 998, and velocity is given 1.1, x is given 0.2 divided by mu is equal to 1.002 into 10 to the power minus 3. So if this value less than or equal to 5 into 10 to the power 5 laminar, if this is greater than 5 into 10 to the power 5 turbulent, your RE, remember please. So if you will calculate these things, your RE will become this much, 219,123.5, means 2.19 into 10 to the power 5 RE, means your laminar condition. So your formula will be used in your question. The boundary layer thickness, delta is equal to x, that is 0.2 into 5 divided by 2.19 into 10 to the power 5 root 1 by 2, or you can say root also. So this is finally will come around, let me just show you. Yes, the finally will come 0.29 mm. So remember please, this is your 5 into 10 to the power 5 is laminar, or you can say the for critical also. So this is overall idea about how you will solve such type of question in your examination. That is the final examination of NPTEL or your whatever examination, your university exam as well as competitive exam. So your which option is correct? 0.29. So option, last option will be correct, H, 2.09 mm. Now we'll move on the question number second numerical. If delta 1, delta 2 are boundary layer thickness. If delta 1 and delta 2 are the boundary layer thickness at point X from the leading edge on a plate, on a flat plate, when the distance are 4 centimeter, 1 centimeter respectively, then the ratio will be. So please try to think on that and try to give your answer. This is very important question. Satyam, you want to say something? Yes, please. No, in pipe flow, you are talking about in pipe flow, but here we are discuss about the, let me just explain. So, in this question, we are discussing about the flow over a plate, right? Flow over a plate. For laminar, it is the, and for turbulent, your Reynolds number will be different when you will, your flow will pipe or your flow in open channel. If I draw here the cross section like that, in open channel, in pipe flow, here Reynolds number is for laminar flow is less than equal to 2000, and for turbulent it should be, when the flow Reynolds number will be greater than 4000 generally. In case of open channel, your Reynolds number should be less than equal to 500 and for greater than your 1000. But in case of plate, when water will flow over the plate, if for laminar it will be 10 to the power 5, for turbulent, here is the Reynolds number, and for turbulent greater than 10 to the power 5. So remember please. This is your doubt, please? Okay. Now please you just try to solve the next question. No. This is not related to fast and this thing. This is not correct definition. Maybe fast flow. This is not correct definition. Laminar flow means what? Flow in layer form. Flow in layer form. This like that. Flow will be very smooth. Okay, I will show you. Don't worry, I will show you today. This is a laminar flow pattern, but in case of turbulent flow, your flow is not like that. Flow will be zigzag like that. Flow will be zigzag. Remember please. So zigzag motion in case of the your turbulent flow, or in laminar flow, very smooth flow. So remember how it look like. You just try to solve this question number 2. Question number 2, this one, and then after I will show you some graph, that is a photo of the laminar and turbulent. So just let me download the PPT. Where let okay, you are telling option B. So hope you the laminar and turbulent flow, whether it is visible or not, please just confirm. One candle is visible. Okay, okay. So the question about the laminar flow and turbulent flow you are talking. So you can just see here. Uh, Up to that much, your flow is up to here, your flow is laminar. You just see the very smooth flow. After that, your flow path is very zigzag type. if you will see here. So this is the, just by visualizing, just I am trying to show you how you will visualize whether it is laminar and turbulent. Now another example also. Another example is, here is some experimental data, some photos. Yeah. So you can see here, this is the your laminar flow, how it look like, very smooth flow. This is also look like very smooth. This flow is look like very smooth, but this is not a laminar flow. This picture is taken from far away. Both figure B and figure C is the similar. The difference is this photo is taken from very near and this figure is taken from far away. So similar, if you will see here, if you will see something from very far away, the flow may be look like very smooth, very ordered, but not. Here is the explanation is with these two figure B and C, but not the your flow is laminar. So remember please these things. It may be from far away, the flow will be visible, very ordered flow, but when we will go near to the flow, then you can very easily say whether it is flow laminar or turbulent. Here if you will see, very zigzag motion type of flow. So when you will analyze these things, when you will capture the turbulent flow by instrument, you will, your instrument will give data like that. From average value, your value will maybe velocity at particular time, at a particular time. If this is your, let's suppose this is open channel, if I draw here and this is water is flowing, if you are measuring at a particular point velocity with respect to time, at that point velocity may be v is equal to, if average velocity I take 1 meter per second, so it may be at that point velocity 1 meter per second. After few seconds velocity may be more than 1 point, maybe 1.2, maybe here minus 0.8, that is 0.8. So it is like that. So your fluctuating velocity, turbulent flow means fluctuating velocity, when we will measure it will look like that. And your laminar flow only smooth flow, velocity will be same, velocity will be same, there is no difference, there is no variation in the flow velocities at a particular point with respect to time. But in turbulent flow definitely it will be vary. So now I want to move on the questions. So here question is, delta 1 and delta 2 are the boundary layer thickness at point X from the leading edge on the plate. So let me just, this is the plate and this is your boundary layer. So let us assume here is delta 1 and here is delta 2. Boundary layer thickness is at point X from leading edge on the flat plate when the distance are 4 centimeter and 1 centimeter respectively. This means their ratio is actually talking about, if this is delta 1 and this is delta 2, so from here this distance how much, from here this distance how much. So here very confusing of the boundary layer thickness at point X. from the leading edge on the flat plate when the distances are 4 centimeter, that is your delta 1 at 4 centimeter and 1 centimeter respectively. So at 4 centimeter definitely your delta 1 will be more, so the naming should be like that, delta 1 and delta 2. So this is 1 centimeter and this is your 4 centimeter, because definitely at 4 centimeter your boundary layer thickness will be more. So what is the ratio between, ratio will be, so delta 1 and delta 2. So if, and here we need to assume the laminar flow. So you know already it is, your delta is directly proportional to root x. So here root x1 divided by root x2. So root x1 is 4 and this is 2, this is 1. So finally it will become 2. So B option will be correct for question number 2. Oh, what is your answer? Let me just see. Okay, you are telling B. Yes, that's good. Now we'll move on the next question. Next question is about question number 3. This is, I think this is the last question. The thickness of laminar boundary layer on a flat plate at point P is 2 centimeter. At point Q is 1 meter. At point Q is 1 meter downstream of P, 3 centimeter. What is the distance of Q from the leading edge of the plate? So please think on that and you have 2-3 minutes. Then after I will explain. Question number 3. Okay, now I want to explain question number 3. So question 3 is about the thickness of boundary layer on a flat plate at point P is 2 centimeter. 2 centimeter, and at point Q, which is 1 meter downstream, this is Q, is 3 centimeter. Little bit higher. So it is like that, maybe boundary here. This is 2 and this is 3 centimeter. Just think on that. What is the distance of Q from the leading edge? So this distance we need to know. If this is x, this is x plus 1. So your formula is, if it is laminar flow, here is laminar boundary layer is given already. So delta at P divided by delta at Q is equal to root x divided by root xq. So this is x and this is x plus 1. Already given, qp is given 2 and delta p is given 2 and delta q is given 3. And x you need to calculate. So take root both sides. So this is 4 divided by, take square both side actually. This is 9 x divided by x plus 1. So when we will multiply 4x plus 4, 9x. So your 9x minus 4x divided equal to 4. This equation will come. So here 5x is equal to 4. X is equal to 4 by 5 means 0.8. X is equal to 0.8 meter. Why meter? Because x, your this distance plus 1 is meter. So that's why here is there is no meaning of the your unit, because centimeter will be cancelled out. So this unit will be important. So it is 0.8 meter. So option x is equal to your 0.8 meter. So in question, what is the distance of q? So up to that much. So distance of p is 0.8. So distance of q will be x plus 1 means 0.8 plus 1, it will be 1.8 meter. So remember please what is question. So option D will be correct for this. So we'll meet in the next question, next session. So for today we'll wind up here. So thank you all. So we'll meet in the next class. Thank you. You want to say something, Sam? Okay, thank you. Okay, thank you.
Okay, no questions. So I can leave it.